Okay, so you sent in a ton of research about materials for building robots. Looks like you're ready to get down to the nuts and bolts, and I mean that literally. So, whether you're prepping for a big project or just brushing up on your robotics knowledge, or maybe you're just super curious about what goes into these mechanical marvels, today's deep dive is all about making sure you know how to pick the perfect material for whatever bot you dream up. We'll be covering a range of materials, from the heavy hitters like all sorts of metals, to the more adaptable plastics and composites. We'll even touch on the really futuristic stuff, like shape-shifting alloys and materials that can actually respond to their environment. It's pretty wild. But before we get ahead of ourselves, I'm curious. From all this research that you've done, what's really stood out to you?
What I think is really fascinating is how your choice of material isn't just about aesthetics. It really dictates what a robot can do. It's about understanding how strength and weight and flexibility and durability and even the ability to safely interact with humans all play together.
Hmm.
If you pick the wrong material, well, it could be the difference between a successful build and a total flop.
You mean a robot that falls apart on its first task?
Yeah.
Yeah, that's that's not a good look.
No.
But you mentioned trade-offs. Can you give me an example of how that actually works in the real world?
Absolutely. Think about steel. It's super strong, which makes it great for robots in industrial settings that need to lift heavy objects. But all that strength comes at a cost, literally. Steel's expensive, and it can be heavy, which can really slow a robot down and make it less energy efficient.
Okay, so then how do you figure out how to navigate those trade-offs when you're choosing materials for a robot?
It's a bit like putting together a puzzle. You have to think about the robot's specific purpose and the environment that it will be working in. So will it be lifting heavy loads? Will it be operating in extreme temperatures? Will it be interacting with delicate objects? Once you've got a good understanding of what the robot will be doing and where it will be doing it, then you can start narrowing down your material choices.
Okay, that makes sense. So let's start with the classic robot material, metal. There's just something about the strength and durability of metal that just screams robot. Wouldn't you say?
Definitely.
Yeah.
And of all the metals out there, stainless steel is definitely a top contender. It's what everyone uses for industrial robots that need to operate in really harsh environments
Yeah.
because it's so resistant to damage and corrosion and even extreme temperatures.
So we're talking about those robots that you see on assembly lines, welding parts or moving heavy machinery.
Exactly. Stainless steel is perfect for those kinds of demanding tasks because it's so strong and resilient.
But what about when you need a robot that's a bit more agile, something that needs to move quickly and efficiently? Does that change which metal you would use?
Oh, absolutely. If you need speed and efficiency, then aluminum is the way to go. It's much lighter than steel, which means you can build robots that are faster and more energy efficient.
So that would be like delivery robots zipping around a warehouse or drones flying through the air.
Exactly. Those are applications that really benefit from using aluminum. Of course, there's a trade-off here, too.
Ah, I knew there had to be a catch. What is it?
Well, aluminum may be lighter, but it's not as strong as steel. So if your robot needs to handle heavy loads or take a lot of impact, you'll probably need to reinforce it with extra supports.
So it's strength versus weight. Got it. But now for the material I'm most excited about, titanium. It's like the superstar of the metal world, wouldn't you say?
Titanium definitely lives up to the hype. It's incredibly strong for its weight. Plus, it's really resistant to corrosion, so it's
Mm.
ideal for a lot of demanding applications.
No wonder they use it in aerospace and even for surgical robots. When you need precision and reliability, titanium seems like the obvious choice.
Exactly. Think about surgical robots that assist with really delicate procedures. Titanium is a perfect fit for those applications because it's so strong and biocompatible.
But with all those advantages, there has to be a downside, right?
Of course, titanium's biggest drawback is the cost. It's a lot more expensive than steel or aluminum, which can be a deal breaker for some projects, and it can be tricky to work with. You need specialized tools and expertise.
So titanium's a great material, but you need to weigh the pros and cons carefully before you choose it. But it's not all about metal, is it? There are tons of other materials out there that we can use for robots. So let's move beyond the heavy hitters and talk about something a little more flexible.
You're right, metal is great, but it isn't always the best solution. Let's talk about plastics. They have a whole different set of advantages.
Plastics, I have to admit, I don't usually think of plastics when I think of robots. So what makes them so useful?
Plastics are incredibly versatile. They're lightweight and affordable, and they're really easy to shape, which makes them perfect for all sorts of applications.
So when would you choose plastic over metal for a robot?
Well, think about robots that are designed for tasks that don't require a ton of strength, like the little robots that are used in education or research, or even entertainment. A lot of those robots use plastic components.
Oh, yeah, like those small programmable robots that teach kids how to code.
Exactly. Plastics are also great for prototyping. They're easy to use and affordable, so you can experiment and make changes to your design quickly.
So if you're testing out a new design, you might start with plastic instead of something like titanium that's super expensive.
Exactly. It lets you refine your design before you commit to using more expensive materials for the final build.
Okay, so plastics are versatile and affordable, but what about when you need a robot that has a gentler touch?
That's where you'd use materials like rubber or elastomers.
You mean for robots that need to handle fragile things? Or robots that will be interacting directly with humans?
Exactly.
Yeah.
Those materials are flexible and they can absorb shock. So they're great for things like robotic grippers that need to pick up delicate objects without damaging them.
Like picking up a ripe strawberry without crushing it.
Exactly. Rubber and elastomers are also really important for soft robotics, where robots are designed to mimic the movements and flexibility of living things.
Oh, wow, that's fascinating. So we're talking about robots that can move through complex environments, like the human body, more easily and safely than traditional robots.
Exactly. These materials are allowing us to create robots that can work more collaboratively with humans and do things that traditional rigid robots could never do.
It sounds like materials science is really changing what robots can do and opening up all sorts of new possibilities for how humans and robots can work together. Okay, so we've covered metals that give us strength and durability, plastics that are versatile and affordable, and rubber and elastomers that allow for a gentler touch. But what about when you need a robot to be able to withstand extreme heat? Is there a material that can handle that?
Absolutely. For extreme heat, you need ceramics. They're known for being able to resist incredibly high temperatures, and they're really durable, which makes them perfect for robots that have to operate in those really hot environments.
Wow, so we're talking about robots that can handle conditions that would melt most other materials.
Exactly. Like robots that are used for welding, or robots that explore volcanoes.
That's incredible. It sounds like ceramics are really pushing the limits of what's possible with robots. So far, we've explored all kinds of materials, each with its own strengths and weaknesses. But now I want to talk about something truly cutting edge: smart materials.
Smart materials are where things get really exciting. They can actually respond to changes in their environment, and they have properties that we can control and manipulate in really interesting ways.
So we're talking about materials that can change their shape or their color, or even how well they conduct electricity, all in response to things like temperature or pressure.
Exactly. One of the most promising types of smart materials are shape memory alloys. These metals can actually remember their original shape, and they can return to that shape even after being deformed.
Wait, so you're saying that you could build a robot with a shape memory alloy and it could change its shape on demand? That sounds like something out of a science fiction movie.
It does sound futuristic, but it's becoming more and more real. Imagine a robot that can adapt to its environment, changing its shape to fit through tight spaces or grasp different sized objects.
That's mind-blowing. So what other kinds of smart materials are being used in robotics?
Another really interesting area is piezoelectric materials. They generate an electrical charge when you apply mechanical stress to them. And we can use that property to create sensors that allow robots to feel their surroundings
Mhm.
or even power themselves through movement.
So robots that can sense their environment and generate their own energy. The possibilities are endless. Okay, so we've talked about metals and plastics and even smart materials. I think it's time for us to take a quick break. But when we come back, we'll continue our exploration of these amazing materials, and we'll see how they're shaping the future of robotics. Stay tuned. Welcome back. We've been exploring all the amazing materials that go into making robots, from the classic strength of metal to the adaptability of plastics. And just before the break, we were starting to talk about the really cutting edge stuff, smart materials that can actually react to their environment. It's like science fiction is becoming reality.
It really is.
So before we get lost in a world of shape-shifting robots, I'm curious, what are some of the practical applications for these smart materials?
Well, the applications are growing all the time as researchers discover more and more things you can do with them. One area where they're already making a big difference is medical robotics. Imagine a surgical robot with instruments made from shape memory alloys.
Oh, so instead of having a whole bunch of different tools, a surgeon could have one instrument that changes shape depending on what they need to do.
Exactly. It could transform from a scalpel to a grasper to a suturing needle, all in the same device.
That's incredible. What other kinds of medical applications are there?
Another exciting area is prosthetics. Shape memory alloys can be used to create prosthetic limbs that actually respond to the user's muscle movements. So it's a much more natural and intuitive experience.
So instead of having a prosthetic that's basically static, it would be dynamic and react to what the person wants to do. That would be huge for people with disabilities.
Okay, so smart materials are really changing medical robotics. But what about other areas, like manufacturing or exploration? Are they having an impact there too?
Definitely. They're making big waves in industrial robotics too. Imagine you have a robotic arm on an assembly line, and it's equipped with sensors made from piezoelectric materials. Those sensors can detect tiny changes in pressure or vibration, which means the robot can handle very delicate components with incredible precision. So you could use these robots to put together complex electronics or work with materials that are easily damaged.
Exactly. It would be a game changer for industries that require a lot of precision and dexterity.
And what about robots that are designed to explore extreme environments? Can smart materials handle that kind of thing?
Oh, absolutely. Smart materials are a key part of developing robots for exploration. Imagine a rover that's exploring the surface of Mars, and it's got wheels made from shape memory alloys.
Oh, that's cool. So instead of getting stuck in sand or on rocks, the rover can just change the shape of its wheels to deal with whatever terrain it encounters.
Exactly. Being able to adapt like that would be crucial for navigating unpredictable environments and making sure the rover can explore as much as possible.
Wow. It seems like smart materials are creating all sorts of new possibilities for robotics. But I imagine there are still some challenges to overcome before they become widely used.
You're right, one of the biggest challenges is cost. Smart materials are still pretty expensive to produce,
Hmm.
which can be a barrier for some people.
So it's a question of balancing the potential benefits with the economic realities. Are there any other hurdles that researchers need to overcome?
Another big one is durability. Smart materials have some amazing properties,
Yeah.
but they don't always last as long as traditional materials like steel or aluminum. Researchers are working on ways to make them more durable and resilient so they can withstand the wear and tear of real-world use.
So it's about making sure these materials are tough enough to be used in the long term. But even though there are challenges, it seems like smart materials are going to be a big part of the future of robotics.
Absolutely. As researchers continue to make breakthroughs in this field, we're going to see more and more innovative and groundbreaking applications for smart materials in robotics.
It's an exciting time to be following this field for sure. Okay, so we've explored metals and plastics and even these amazing smart materials. But now I want to talk about something that's completely revolutionizing how we design and build robots.
Hmm.
3D printing.
3D printing is a total game changer for robotics. It allows us to create really complex parts with a level of precision and speed that we've never seen before. Imagine being able to design a robot part on your computer and then just print it out in a few hours.
So instead of having to go through traditional manufacturing processes that take forever and cost a fortune, 3D printing lets you create exactly the part you need when you need it. That's amazing. How is this impacting robotics?
One of the biggest impacts is in prototyping. With 3D printing, you can quickly create and test different versions of a design before you finalize it, so the design process is much faster, and there's more room for innovation and experimentation.
So instead of spending weeks or months tweaking a Docker, design engineers can test out all sorts of different ideas in a matter of days. That's a huge advantage.
Exactly. And because 3D printing lets you create shapes that would be impossible to make with traditional methods, it opens up all sorts of new design possibilities for robotics.
So we could start seeing robots with really intricate organic shapes, almost like something you'd see in nature.
Absolutely. Bio-inspired robotics is a growing trend. And 3D printing is playing a huge role in that movement because it allows us to create robots with these complex nature-inspired designs.
That's fascinating. So 3D printing isn't just making it easier and faster to develop new robots, it's also changing what we think of as a robot.
Exactly. And it's not just about the design possibilities. 3D printing is also making robotics more accessible.
What do you mean by that?
Well, traditionally, building robots was something that required a lot of specialized equipment and expertise, which was expensive and time-consuming. But now that we have these affordable 3D printers, hobbyists and students and small businesses can create their own robot parts and even build entire robots from scratch.
So 3D printing is democratizing robotics in a way and allowing people who might not have had the resources to do this before to get involved. That's really cool. But with all this talk about how amazing 3D printing is, are there any limitations or challenges that we should be aware of?
Of course, like any technology, it has its limitations. One of the main challenges is material selection. While the range of materials you can use for 3D printing is growing all the time, it's still not as diverse as what you can use with traditional manufacturing.
So for some applications, you might still need to use those traditional methods if you need a specific material.
Exactly. Another challenge is scalability. 3D printing is great for prototyping and for small-scale production, but it can be difficult to use it for mass production.
So for really large-scale manufacturing, the traditional methods might still be more efficient and cost-effective.
Exactly. But even with those limitations, 3D printing is a truly transformative technology, and it's having a huge impact on robotics.
Okay, so we've talked about a whole bunch of materials used in robotics, from the very basic to the super futuristic. And we've discussed the strengths and weaknesses of different materials, and the trade-offs you have to consider when making your choice, and how technologies like 3D printing are changing the game. But I'm curious, with all this knowledge, how do you actually go about picking the right material for a particular robot? It seems kind of daunting.
It is a crucial step in the design process, and it takes careful consideration.
So what are some of the key things you need to think about?
Well, the first and most important thing is what the robot is going to be used for. What
Reach-
tasks will it perform? What kind of environment will it be operating in?
So if you were building a robot to explore the bottom of the ocean, you'd need to use materials that can handle extreme pressure and corrosion.
Exactly. And if you're building a robot that's going to be interacting with humans, you'd want to use materials that are safe and lightweight, maybe even something with a soft texture.
So there's no one-size-fits-all solution. It all depends on what you're using the robot for.
Exactly. And you also need to consider things like cost and durability and even aesthetics.
So you have to weigh the pros and cons of different materials to find the one that works best for your project.
Exactly. And it's not always about choosing just one material. A lot of robots use a combination of different materials, each chosen for its specific properties and purpose.
It's like putting together a puzzle. You have to use the right pieces to create a machine that works the way you want it to.
Exactly. And as material science continues to advance, we're going to see even more innovative materials and manufacturing techniques, and that's going to lead to even more amazing robots.
It really is a fascinating time to be involved in this field. So in this episode, we've covered a lot of ground. We've explored this fascinating world of robot materials. And we've seen how material science is shaping the future of robots, from industrial workhorses to delicate surgical assistants. And we've even caught a glimpse of the future, a future with smart materials and advanced manufacturing techniques that are going to push the boundaries of what's possible. But before we wrap up, I want to leave you with one final thought. As we continue to create more and more sophisticated robots, it's important to remember that there's more to it than just the technical aspects. We need to think about the ethical implications of integrating these machines into our lives.
That's a very important point. As robots get smarter and more autonomous and more integrated into our daily lives, we really need to think carefully about how that's going to impact society. It's not just about what we can do, but what we should do.
Right, like we talked about robots in manufacturing. Increased automation could lead to a lot more efficiency. But what about all the people who might lose their jobs to robots?
Exactly. We need to think about those consequences and start figuring out solutions. Maybe we need to create retraining programs for workers. Or maybe we need to completely rethink our economic models.
We also talked about robots being used in healthcare to do things like perform surgery or assist with caregiving. What are some of the ethical things we need to think about in those scenarios?
Well, when you have robots making decisions that could directly affect people's health and well-being, you have to have really clear guidelines and safeguards in place. What happens if a robot makes a mistake? Who's responsible? How do we make sure everything is transparent and accountable? These are difficult questions, but they're important ones.
And it's not just about physical safety. What about the emotional impact of having robots that are more and more integrated into our lives?
That's another really important aspect. As robots become more sophisticated and even start to mimic human emotions, it raises all sorts of questions about how we perceive them and how we interact with them. Are we going to form bonds with robots? Will they become our companions? What does that mean for our relationships with each other and for our social structures?
It's almost like we're entering this completely new world of human-machine interaction, and we're going to have to figure out how to navigate it.
And be willing to adapt and embrace new possibilities.
Hmm.
Remember, throughout history, new technologies have always brought about anxiety and uncertainty, but they've also led to incredible progress and innovation.
It's about finding a balance, isn't it? Embracing the potential of robots, but also acknowledging the challenges and making sure we're developing and using them responsibly.
Absolutely. The future of robotics isn't set in stone. It's something that we all have a hand in shaping. through our choices, our research, our conversations, and our commitment to creating a future that benefits everyone.
That's a good reminder. So, for our listeners who've been with us on this deep dive into robot materials, what's the one thing you'd like them to take away from this?
I'd say remember that as you explore the possibilities of building robots, the choices you make about materials are about so much more than just their physical properties. They're choices that are going to shape how these machines function and how they look, and ultimately how they impact our world.
It's about looking beyond the technical specifications and thinking about the bigger picture.
Exactly. And never stop asking questions, exploring new ideas, and having these important conversations about the future we're creating.
This has been such a fascinating journey through the world of robot materials. We've covered a lot, but I feel like we've only just scratched the surface.
It's a constantly evolving field, and it's been great sharing this exploration with you and our listeners.
And to all our listeners out there who are clearly as interested in this topic as we are, thank you for joining us on this deep dive. We hope you've gained a new appreciation for this amazing world of robot materials and all the incredible things that are on the horizon. And as you continue to explore robotics on your own, remember the words of our expert: be curious, be responsible, and never stop imagining the future. Welcome back. We've been talking about all the different materials that go into making robots, everything from basic metals and plastics to those incredible smart materials and 3D printing. It's been quite a journey. But like we've been saying, this is about more than just nuts and bolts. It's about
Mhm.
how technology and humanity intersect and the choices we make as we create machines that are becoming more and more a part of our lives.
Exactly. It's a good reminder that material science isn't just about strength and durability. It's also about how we're shaping the future, the tools we create, and the whole relationship between humans and technology.
And you mentioned the ethical considerations that come with advanced robotics earlier. I think that's where things get really interesting and something for our listeners to really think about.
Definitely. As robots become more intelligent and more independent and more integrated into our lives, we need to think critically about what that means. It's not just about what we can do, but what we should be doing.
Right, like when we talked about robots being used in manufacturing, more automation could mean more efficiency, but it also makes you wonder about what happens to all the jobs that humans used to do.
Exactly. It's important to think about those potential impacts and come up with solutions like maybe we need to create programs to retrain workers, or maybe we need to completely rethink our economic models.
We also talked about robots being used in healthcare, doing things like performing surgery or helping with caregiving. What are some of the ethical considerations there?
Well, when you have robots making decisions that could affect people's health and well-being,
Yeah.
you have to have really clear guidelines and safeguards in place, like who is ultimately responsible if a robot makes a mistake, and how do we make sure that everything is transparent and accountable? These are tough questions, but they're ones we have to address.
And it's not just about physical safety either,
Yeah.
right? What about the emotional impact of having robots become more integrated into our lives?
That's another important point. As robots get more and more advanced and can even mimic human emotions, it brings up all these questions about how we see them and how we relate to them. Will we start forming bonds with robots? Whether they become like companions to us? What will that mean for human relationships and our social structures?
It's like we're stepping into this whole new world of human machine interaction, and we're going to have to figure out how to navigate it.
And be willing to adapt and be open to new possibilities. I mean, if you look back at history, new technologies have always made people anxious and uncertain, but they've also led to amazing progress and innovation.
It's all about finding that balance, embracing the potential of robotics, while also acknowledging the challenges and making sure we're developing and using them responsibly.
Exactly. The future of robotics isn't something that's set in stone. It's something we all have a role in shaping through the choices we make, the research we do, the conversations we have, and our commitment to creating a future that benefits all of humanity.
That's a great point. So, for our listeners who've been with us on this journey into the world of robot materials, what's the one thing you'd like them to take away from all of this?
I would say, as you're exploring the possibilities of building robots, remember that the choices you make about materials go way beyond just their physical properties. Those choices are going to determine how those machines function and what they look like, and ultimately what kind of impact they have on our world.
So, it's about looking beyond just the technical specs and considering the bigger picture.
Exactly, and never stop asking questions, exploring new ideas, and having those thoughtful conversations about the future we're all building together.
Well said. This has been an incredible journey through the world of robot materials. We've covered a lot of ground, but I feel like we've only just scratched the surface.
It's a field that's constantly evolving, and it's been a pleasure sharing this exploration with you and our listeners.
And to our listeners who've been with us every step of the way, thank you for joining us on this deep dive. We hope you've gained a new understanding and appreciation for the amazing world of robot materials and the incredible possibilities that lie ahead. And as you continue your own explorations in robotics, remember the words of our expert: be curious, be responsible, and always keep imagining the future.